In this video, we'll look at Chapter 7, Section 4, when we talk about acids and bases in solution. So taking some of those acid and base properties that we already talked about, and then talking about what happens when they're in solutions. So when they're in solutions, acids have a tendency to produce hydrogen ions. So that means that they're going to make the hydrogen break off from the acid. And that is a key indicator that is an acid, is when there's hydrogen that's breaking off. As you can see in the picture down at the bottom, they have, at the beginning, they have acid bonded with hydrogen, and then at the second part, after it's been added to water, the hydrogen atoms break off, and that's what they're talking about. So that's the release of those hydrogen atoms, ions. The ions that are being released cause the properties of acids. So when we're talking about hydrogen gas being released, or we're talking about the change in color of the litmus paper, those are because of reactions with that hydrogen. And so that's just building off of what we talked about in 7.3. In order to have hydrogen break off from the acids, acids have to include hydrogen in their chemical makeup. And so that's another way to kind of help figure out what, if it's an acid or a base, is if it has hydrogen in it, it's going to be, if it has only hydrogen instead of hydroxide, which we're going to talk about. So bases, similarly, have something that breaks off, but this time it's going to be hydroxide ions. So they have OHs that are bonded together that break off. So what I was just talking about with the chemical makeup, you have to make sure there's hydrogen in the acids, but in the bases, you have to make sure that there's hydrogen and oxygen bonded together so that they can produce hydroxide ions when they're in the water. Those hydroxide ions are what are responsible for that bitter taste or that slippery feel that we talked about in 7.3. So there's another picture up here on the top. When we have an acid mixed with a base, we're going to end up with our hydrogen ions floating around. And then when we have a base with water, we're going to have our hydroxide ions floating around. There's different strengths of acids and bases. So you can have like a weak acid, you can have a strong acid based off of how many of those hydrogen ions are breaking off. So we use the pH scale to represent bases all the way up to acids. So we have any range from 0 to 14 on that pH scale, okay, and it's the concentration of hydrogen ions. pH actually stands for potential of hydrogen, so that's what the pH part is for. So things that have a low pH are going to be acids, and things that have a high pH are going to be bases. Okay, there's lots of different indicator papers that you can use to check the actual pH of different items and see if they are more acidic or if they are more basic. When we have a reaction between an acid and a base, it's called a neutralization. So when we're talking about things that are neutral, they're going to have a pH of 7 because it's going to fall right in the middle of that pH scale. When you mix an acid and a base, they're going to react in such a way that they create water, and then they also create what's called a salt. It's not actually salt like NaCl. It's not what they're talking about. What they're talking about when they're talking about a salt here is they're talking about like some kind of precipitate that is in solid form. So there's going to be some kind of chunks that they call salt from these reactions. Okay, so that's what's made when you mix. You can see in this picture an acid and a base. In a neutralization reaction, it's going to create a salt, which is just the precipitate, and it's going to create, and it's going to have water. All right, so that's going to wrap up 7.4, where we're looking at acids and bases in solution.